Hello students, welcome to Distinction Learning Platform. In this video, we are looking at Oogenesis. So before we begin this video, make sure that you subscribe, comment and like the video. And in the comment section, there's a link that will take you to the website where you find now other educational videos. Alright, now what is this Oogenesis that we're talking about here? Oogenesis simply means that it talks about the development of the mature oocyte from the germ cells. So we're saying oogenesis basically is just the development of mature oocytes from the germ cells. Okay, mature oocyte from the germ cells. Now, from that definition, basically we need to highlight important terminology that will help us to understand the whole process of oogenesis. So, what are those important terminologies? This one, germ cells, as well as we understand the mature oocyte as well. So now, what are these germ cells? So germ cells basically, these are the stem cells that basically begin in the fetal life and progress into the adult life up to the puberty life. Now, let us look at these germ cells, particularly the location of these germ cells and why are they important to talk about them. Right? Now, in fetal life, we'll look at week 3. Okay? Just to make sure that you remember, in week 1, we said that's where you can find implantation as well as fertilization. In week 2, remember that comprises of what? We're going to find there the embryoblast as well as the hypoblast and the epiblast. Then in week 3, that's where gastriation is going to happen, and the majority of organs, that's why they are going to start developing. Okay, so that's why we're picking week 3, because gonadal the one that are going to develop into ovaries, that's where they will start developing. Okay, that's why it's important to start from week 3. So now let us look at this important structure of a fetus around week 3. You've got this structure, which is the yolk sac. Okay, this important structure is what we call allantois. We'll look at the importance of that. And we have this important structure which we call gonadal ridge. Then the last one is this one, mesonephros. Okay, so these are the important structures that are going to help us understand the oogenesis. Okay, now the question that we can ask is that these stem cells or these germ cells, where can you find them in the fetus? You can find them in the what? Yolk sac. Here. In the yolk sac. So these are germ cells that are there. Alright? You can find them in the yolk sac. Now, specifically where in the yolk sac? Because if you look at the yolk sac, it is a very big structure. So we need to specify where can you find these germ cells. So particularly, you can find them near the allantois structure. So as you can see, this is an allantois structure. Remember that allantois structure is a very important structure because it will participate in the development of the hindgut. You need to remember on that. Alright? Now, these germ cells, they are going to have a specific name in the fetal life. So we're not just going to be calling them germ cells. We'll call them the primitive germ cells. So let us write that word. So a very important word. Primitive germ cells. Sometimes they call them PG cells. Okay? PG cells. Primitive germ cells. So these are the ones that are found in the yolk sac just near allantois structure. Now, the question that you can ask is that how do these primitive germ cells find themselves in the gonadal ridge? They simply migrate. Okay? They will simply migrate. So they will migrate up to the gonadal-ridges. Okay, they will migrate like that. Okay, and this migration particularly is going to happen around week 4 to week 6. That's when these primitive germ cells, they are going to start migrating. All right, and this migration is very crucial or important, because if these germ cells, they do not migrate, they will develop into what we call tumors or cancer. So no wonder it is crucial for them to start migrating around 4 to 6 weeks. Now, upon reaching the gonadal ridges here, and remember that the gonadal ridges, these are the one that will develop into either the male. So let us start with the male gonads, or the female gonads. Okay, again, these gonadal ridges, we know that they are going to develop either in male gonad and female gonads. Again, the question that you might ask is, how do these gonadal ridges know that we need to develop into the male gonad or the female gonad? Okay, it is because of this simple reason. Remember that these gonadal ridges, they are receiving the primitive germ cells, and those primitive germ cells, they are carrying certain chromosomes. And what are those chromosomes? They are carrying XX chromosome. So these are primitive germ cells, and remember that they are carrying XX chromosome. Why do I say so? Because these XX chromosomes, we are talking about the oogenesis that will basically happen in female embryo or fetus. All right. So no wonder female fetus, they are going to have this XX chromosome, and in male fetus, they are going to have XY chromosome. So now, these XX chromosome, these are the ones that will stimulate these gonadal ridges to start developing into female what? Gonads. Okay, that's how they develop into female gonads, simply because of those XX chromosomes that are coming from the female primitive gonads, or female primitive germ cells. All right, now, since we've understood about how these gonadal ridges are going to develop into the female gonad, and anatomically where you can find these gonadal ridges specifically, you can find it in the what? Posterior abdominal, or anteriorly to the what? Mesonephros. Again, where can you find these gonadal ridges in the fetal life? You can find them just anterior to the what? Mesonephros, and in the posterior abdominal region. All right. Now, since we've understood about that, now let us go back to these PG cells. Okay. Let us understand about these PG cells. Okay. PG cells, or primitive germ cells. Now, what's going to happen is that let's try to imagine to say this structure, it is an ovary which has been cut in cross section like that, so that we can simply see what's happening inside these ovaries. Okay, so now, upon this, if the fetus is growing and the gonadal ridges are developing into the female gonads, particularly the ovaries, oviduct, uterus, as well as the vagina, all those structures. So upon developing that, also these primitive germ cells will start proliferating, becoming many in number, and changing into something important. Okay, so these primitive germ cells, they will start changing into these important what? Cells. What do we call these cells? We call them oogonia. Okay, we need to understand on that. Again, primitive germ cells, as the fetus is growing, developing, also these PG cells, they will start proliferating, dividing, and differentiating into what? Oogonia. Okay, and by the process called mitosis. Okay, we need to understand on that. Now, these Oogenesis cells, they'll start again differentiating into also something important. Okay? These Oogenesis cells, they'll start changing into something important, which is particularly this cell. Okay? So this, let's just pick one Oogenesis cell, then it will change into this cell which we call the primary oocyte. Okay, so this is the primary oocyte. Primary oocyte. Okay, and we need to take note that these two processes, two important processes, are happening before birth. Okay, we need to take note on that. Okay, the PG cells changing into Oogenesis, then Oogenesis changing into the primary oocyte. These processes, they're happening before birth, and particularly this is also mitosis. This process, particular, that is also mitosis. So this is mitosis and this is mitosis, where Oogenesis cells are changing into the primary oocyte. And again, an important concept that you need to take note is that the number of chromosomes of the primary oocyte, the Oogenesis, and the primitive germ cells. Okay, how many chromosomes that are there? So we need to remember that it is about 46 chromosomes. Basically, if you remember the formula, it is 2n. Okay, n stands for the number of chromosomes from each parent. So if you look at n, there are particularly 23 chromosomes. If you multiply by 2, you are going to have now 46 chromosomes. From the maternal, we are going to have 23. From paternal part, we are going to have 23. Altogether, we are going to have 46 chromosomes. Again, for Oogenesis, we are going to have 46. For the primary oocyte, we are also having what? 46 chromosomes. Take note of that, right? Now, these primary oocyte, they will start differentiating into other cells now. Okay, other important thing that's going to start happening. Now, these, they will start happening now at puberty. Okay, so all the processes that I will start talking about here, down here, going like this, they will start happening after puberty. Now, since we're talking about it at puberty, before we go to these events that will start happening here, let's talk about something important. Okay, an important axis that will help us to understand now the processes that will happen here. All right. So, what is this? Particularly, this is the hypothalamus. Okay, and this is these are pituitary. Okay, this is just basically the pituitary gland. Okay, so this is the hypothalamus, the pituitary gland, and particularly this is going to start functioning during what? Puberty, not before puberty. If this is before puberty, it is non-functioning. Reason being because it's not mature. So at puberty now, this will start doing something to the ovaries that will start now seeing the events here. So what are we saying? So what we're simply saying is that these events, they will start happening during what? Puberty. So let's just say at puberty. So need to take note at puberty. So what's going to happen is that the hypothalamus will start producing certain hormones which we call gonadotrophin releasing hormone. Okay, gonadotrophin releasing hormone. Okay, so that's the hormone released by the what? The hypothalamus. And in the pituitary gland, if you remember, the pituitary gland is going to have two important parts or regions: the anterior region and the posterior region. The anterior region, we call it the anterior pituitary. The posterior region, we call it the posterior pituitary. But this hormone will come here in the anterior region and stimulate the cells in the what? Anterior region, so that they can start what? Producing two important hormones that are important in the what? This event that we talk about here. What are those? Follicle stimulating hormone, FSH, and luteinizing hormone. Okay? We need to understand all that. So, again, the hypothalamus pituitary gland, they are going to start functioning at puberty, and whereby they'll start releasing gonadotropin, releasing hormone that will go to the anterior pituitary gland, that will start releasing two important hormones, which we call follicle stimulating hormone as well as the luteinizing hormone. Alright? Now, these two, the follicle stimulating hormone and the luteinizing hormone, they will start stimulating the oocyte. Okay? Reason why you start stimulating the oocyte is because of the oocyte initially was arrested in a certain stage. Okay? So the reason why the oocyte didn't mature into the event that we'll start talking about, because it was arrested in the what? In a certain stage. Okay? It was arrested in the what? Certain stage, which is what? Process 1 of meiosis. Okay, so this one, again, an important concept that you need to remember is that these oocytes, although they began meiosis 1, but they were arrested in what? Process 1, okay? And that state of process 1 is what we call, you need to remember this one because we are going to be examined on this, which is the diprotein stage. Okay? Diprotein stage. Again, the reason why this primary oocyte didn't go into the certain event that we talk about, because it was arrested in the what? Process 1 of meiosis 1. Okay, and that stage in process 1 is what we call the diprotein stage. Okay, it was arrested. Now, this follicle stimulating hormone and luteinizing hormone will come to this primary oocyte and do something. They are not going to change the primary oocyte, but they will start giving something to the primary oocyte so that it can start developing. Okay, so the first event that's going to be observed here is this one. Okay, it's this one. This is the primary oocyte, so I'm going to decrease the primary oocyte. So this is the primary oocyte that is initially there. Now, it's going to be surrounded by flat cells. Okay, it's going to be surrounded by flat cells. So these are flat cells, if you look at them. Okay, it's going to be surrounded by what? The flatty cells. Anyway, so let me do this so that okay, this is the primary oocyte. Then it's going to be surrounded by what? The flat cells. So these are the flat cells that are surrounding this, okay, this primary oocyte. And since now there are some cells that are surrounding this primary oocyte, and there will be a glycoprotein that's going to be what? Also produced, so that it protects this primary oocyte. So there will be a glycoprotein that's going to protect that oocyte. Now, let us try to identify the most important structures. So these flat cells, we call them follicular cells. They are very, very flat. And this red structure, we call it zona pellucida. Okay? So we call it zona pellucida. Okay? It's more like a glycoprotein that is basically surrounding the primary oocyte and protecting the primary oocyte. And inside there, that is the what? Primary oocyte. What do we call this whole thing? Comprising of the follicular cells, the zona pellucida, as well as the primary oocyte. What do we call this? We call it now So comprising of all these, we call it the primordial follicle. Primordial follicle. Okay? So again, the primordial follicle is going to comprise also of what? Comprise of follicular cells, zona pellucida, as well as a primary oocyte. The zona pellucida is what? It's more like a glycoprotein that is covering the primary oocyte. And did you notice any chain to the primary oocyte? No, there is no chain to the primary oocyte. Basically, the primary oocyte has just been arrested in the meiosis 1, prophase 1, and that stage is what we call the diprotein stage. Alright? And what is stimulating this stage? What is stimulating this state? The follicle stimulating hormone and the luteinizing hormone. These are the ones that are stimulating the oocyte to start developing into the primordial follicle. Alright? Again, so let me put now, here we are saying this is happening after. It is at puberty. Okay, we need to take note of that. So this stimulation is happening at puberty. Let's go. So again, another thing is going to happen to this follicular, to this primitive follicle. Okay, it's going to happen. Now, what will start happening is that if you look at these flat follicular cells, they will start changing into the cuboidal what type of cells. Okay, so what we're simply saying is that this, so we're going to have the same structures, which is this one. We remember that this is the primary oocyte, okay, and this is the zona pellucida, but something is going to start happening here. Okay, as you can see, these cells now, they are more like cuboidal. They are not flat, but they are more like cuboidal. Okay, so these are follicular cells. So these follicular cells now, they are more like cuboidal. Now they are surrounding this the primary oocyte. The primary oocyte that comprises of what? Now the zona pellucida. The name is going to change now. The name is going to change. From the primordial follicle now we are going to have the primary follicle. So this one we're going to call it what? Primary follicle. So let us write from here. This is now the primary follicle. Okay. Now, these cuboidal cells, we're not going to call them follicular cells. The name is going to change because the cells they have been what? Changed into the cuboidal type of cells. They were flat initially. That's why we are calling them follicular cells. But here now they've changed the shape, which is in form of cuboidal. We're going to call it what? Granulosa cells. So we're saying that these cells are going to change the name into what? Granulosa cells. So then let me use blue. So these cells now we're going to granulosa cells. Okay? As you can see the changes. Okay, these are what we call granulosa cells. Alright? Again, these all stages, they are all stimulated by follicle stimulating hormone as well as luteinizing hormone. Okay, let us proceed. Another important event is going to start happening here. So if you look at these granulosa cells, quite alright. Again, the primary oocyte is not going to change. Still, it has been arrested in the what? Meiosis 1. Don't forget. It has been arrested in what? Meiosis 1. It's not changing inside there. Okay, it's not changing. So what's going to happen again is that these granulosa cells, okay, now something outside the granulosa cells will start happening. Again, we're going to have the same structure. We're going to have the same structure. We're going to have the same structure. with these granulosa cells. Okay, so look at the function of these granulosa cells in at another stage. So these are granulosa cells like that. Now, what will start happening is this outside the granulosa cells, there will be some cells that will start developing now. Let us write in blue these cells. Okay. Like that. Okay. And these, the bigger ones. Okay. Now, this is the interesting part. If you look at it's the same structure now. It's just that outside the granulosa cells, there will be now two important cells that are going to start developing. Okay. If you look at the smaller one which is inside, which is near to the granulosa cells, we call them thicker interna. So what do we call them? We call them thicker interna cells. Okay. Then these bigger ones, we call them thicker externa. Thicker externa cells. Thicker external cell. And now we're not going to call this now this whole structure comprising of the thicker external, thicker interna, the zona pellucida, as well as the primary follicle inside there. Okay, what we call this? We call it now the secondary follicle. So this is now the secondary follicle. Okay, so up to this stage, let's come back here so that we revise everything that we've talked about up to this stage. So we said everything is starting before birth. So before birth, we're having the primordial germ cells that are dividing, becoming many in number, so that now they can differentiate into oogonia by, this is mitosis, right? Now, this oogonia, they'll start now undergoing mitosis, becoming many, and becoming what we call the oocyte. This oocyte now, they'll start undergoing what we call meiosis 1. That will now going to be arrested in prophase 1, which is under the diprotein stage. After that now after you have the primary oocyte, then they are going to be arrested for some time. They are not going to start changing up until you reach what? Puberty. At puberty, the hypothalamus and the pituitary gland, they are mature to start producing what? Hormones, which is the gonadotrophin releasing hormone that will act on the anterior pituitary, that will start producing the follicle stimulating hormone and the luteinizing hormone. These two important hormones, they will start stimulating this primary oocyte that was initially arrested in meiosis 1, prophase 1, diprotein stage, to start changing into what? The primordial follicle. Remember, the primordial follicle comprises of what? The follicular cells which are flat with a zona pellucida. Okay? Then again, this stage is going to be stimulated into the forming what we call the primary follicle. The primary follicle is going to have the granulosa cells, the zona pellucida, as well as what? The primary oocyte. Alright, the primary oocyte is not changing. So we'll look at when the primary oocyte is going to change. Okay, at this stage now, if you look at it outside the granulosa cells, they will start developing the thicker external and the thicker internal cells. Okay, and we're going to call it this cell as the secondary what? Follicle. And again, it's going to be stimulated by what? Luteinizing hormone and the follicle stimulating hormone. Now we continue the stage. So at this particular stage now, we need to talk about something which is important. Okay, so you need to pay attention to this one now. Okay, so I'm going to look at the thicker internal cells because they are these are the ones that are going to start producing certain hormones. Okay, so I'm going to magnify the thicker interna. If this is the thicker interna cell, okay, and this is the granulosa cell. Okay, so this is the thicker interna, and these are granulosa cells. Okay, something will start happening here. Okay, they'll start producing now active hormones. Okay, so the thicker interna cells, they're going to be acted by what? Okay, they're going to be acted by what we call the luteinizing hormone. So there are some receptors on this. So this is now the luteinizing hormone that's going to activate the thicker internal cells. Okay, and these thicker internal cells, they'll start what? They'll start producing what we call androgens. So now they'll start producing what we call, if they are stimulated by luteinizing hormone, they'll start producing what we call androgens. Okay, and these androgens will be taken up by the what? Granulosa cells, the one in black. These granulosa cells to start doing something now. Now, before they start doing anything, these granulosa cells, they're going to be also stimulated. So they just don't do anything to those androgens minus being stimulated. They're going to be stimulated by what? Follicle stimulating hormone. So this is also another hormone produced by the anterior pituitary gland. It is the follicle stimulating hormone. So what's going to happen is that these androgens now, they're going to be converted into what? Into estrogen. Into estrogen, okay? So these androgen that were like initially in the granulosa cells, upon being stimulated by the follicle stimulating hormone, these granulosa cells, they will start taking these androgens and convert them into estrogen, okay, by the help of these important enzymes which we call aromatase enzymes. So this is what happens, and this whole process basically starts talking about the production of what? Estrogen. Okay, you need to take note of that. So estrogen produced by the granulosa cells, androgens are produced by the thicker internal cells. But estrogen cannot be produced if the thicker internal cells are not working. So because they are like more like exchanging things here, so they are communicating with one another. Okay, so this is what happens on this stage. Okay, now we can continue. Now, what will start happening in these secondary follicle? Okay, secondary follicles. So what will start happening is this. So inside this secondary follicle, there will be some fluid that will start appearing. Okay, after those fluid spaces, they will start merging to one another and become one large fluid space called the antrum. Okay, so what we are simply saying is this. So I'm going to draw it here again. So again, this is the primary oocyte. It's not changing. Now, what we're simply saying is that inside these granulosa cells, inside the granulosa cell, there will be some spaces filled with the fluid that will start developing there. Okay, and this is the space that we're talking about. Okay, and quite right, we're going to have the granulosa cells which are here. These are granulosa cells. Okay, and there will be some granulosa cells that are surrounding. Remember, before we write that, there will be a zona pellucida that is there. Okay, surrounding the primary oocyte, and there will be some granulosa cells that are surrounding now this. Okay. Now, there will be also the thicker internal cells and external cells. Okay, like that. These are the granular cells in black, the thicker internal and the external cells. Now, this primary oocyte is going to be connected to this follicle by these granular cells. As you can see, there is a stalk that will be here. Okay. Now, what do we call this? What do we call this? Whereby the secondary oocyte will undergo some like certain development where we're going to have the spaces there as well as now, but nothing is changing. We're just having a fluid inside this follicle. What do we call that follicle? We call it the antral follicles. So what do we call these follicles? We call them antral follicles. Why are we calling them antral follicles? Because there is this space. What do we call this space? This space we call it what? Antrum. Okay. Now, there will be something that we need to take note here. Okay. There will be also these granular cells. Remember that these cells in black, we call them granular cells. So these granular cells now, we're not going to be calling them these granular cells because they are separated by these granular cells. There is a space between them, so mean that we need to change this name, these granular cells. Okay, we're going to call them what? Corona radiata. So what are we going to call them? We're going to call them corona radiata. We're going to call them corona radiata, but particularly these are just basically the granular cells. Okay, but since they are just surrounding the oocyte, the primary oocyte, basically we're going to change the name, which we call corona radiata. And remember that there is a stalk that is connecting the primary oocyte to this follicle. What do we call that? What do we call that stalk? So what do we call that stalk? This stalk which is connecting the primary oocyte to the follicle. What do we call that? We call it cumulus operans. Okay, cumulus operans. Okay, that's the name for that stalk that is connecting the what? The primary oocyte to the follicle. But basically, these are also a group of what? Granular cells that are just connecting the primary oocyte to the what? To the follicle. We call it, which is cumulus operans. All right, and because of these changes that we've talked about, or the changing of these names, we're not going to call it a secondary follicle, but we're going to call it the antral follicle because there is an antrum there, which is the fluid-filled cavity. All right. Now, the last important stage. So this is the last important stage that's going to happen now. Okay. Now, upon development, so this antrum or antral follicle, upon developing, it will start now maturing into a very important follicle, which we call the Graafian follicle. Okay, so this one basically is just the same structure. So it's going to have the same structure. We're going to have, okay, we're going to have the primary oocyte. Okay, we're going to have, what do we call that? We say that is now the zona pellucidum. Okay, surrounded by what? These important granular cells, which we call them as corona radiata, and there will be a stalk of these granular cells, which we call the cumulus operans. Okay, that will be connected to what? These granular cells, like that. These granular cells. Okay, remember that these granular cells, they are going to be surrounded by what? Okay, they're going to be surrounded by thicker internal and the thicker external cells. But the major difference between the two is that this is the mature follicle, and these thicker external, thicker internal cells are going to be thick. the granular cells are going to be more active, and also the primary oocyte now, it will start doing something. Okay, so now what's going to happen is this one. So you need to pay attention on this one now. So this is what we call, so let us write this step, which is this one. We call it the Graafian follicle. So we call it Graafian follicle. Okay, so now since the Graafian follicle is more like it is mature and it is more active. If it is more active, what's going to be happening is this. It will start producing remember what it was producing. It was producing what? The secondary the secondary follicle or the antrum, it was producing what? It was producing the estrogen. Now the moment it reaches the Graafian follicle, the amount of estrogen is going to go up in blood. Okay? So what we're saying is that if this is estrogen, so the amount of estrogen in blood will go up. So it's going to increase massively. Why? Because now the Graafian follicle, they have matured and they are producing a lot of estrogen by this process that we talked about. Okay, now if they see a lot of estrogen here, what's going to happen is that they'll go to the hypothalamus, also the pituitary gland, to stimulate. So they'll go where? To this axis and give what we call the positive feedback, because they are stimulating now the hypothalamus as well as the pituitary gland to start producing now massive of what? Luteinizing hormone. Okay, again, what is happening here? We're saying the Graafian follicle, since they have matured enough, they produce massive amount of what? Estrogen in blood, and massive amount of estrogen in blood, it will go to the hypothalamus, stimulate the hypothalamus or the pituitary gland to start producing a lot of what? Luteinizing hormone. A lot of luteinizing hormone, what we call that? We call it luteinizing surge. Luteinizing hormone surge. So we call it luteinizing hormone surge. Okay, so take note of that. Luteinizing hormone surge. So this is what we call luteinizing hormone surge. So let us write it here. Luteinizing hormone surge. It will happen on the Graafian follicle. Okay, it will happen on the Graafian follicle. Luteinizing hormone surge. If that happens, remember that luteinizing hormone surge, basically it will promote what we call ovulation. But before ovulation happens, something interesting is going to happen to the what? Primary oocyte. Find that now the primary oocyte. So something is going to start happening to the primary oocyte. So we need to write now that. So what's going to happen due to luteinizing hormone surge? So we're saying due to luteinizing hormone surge, what's going to happen? Remember that this is now the primary oocyte. What's going to happen to that primary oocyte? Remember, it was stuck in meiosis 1. Okay, probably that should be prophase what? Prophase 1. It was stuck in prophase 1. Now what's going to happen is that if there is luteinizing surge, it will stimulate this now. It is stimulate now the completion of what? The meiosis 1, or in prophase 1 to what? Now the complete of meiosis. So we're saying that this cell is going to now complete this meiosis 1. Okay, it's going to complete this meiosis 1. The moment it's complete meiosis 1, it's going to change the name into the what? Secondary oocyte. Okay, we need to take note of that. Okay, so we're saying just before ovulation happens, this oocyte is going to change into what is the secondary oocyte. And remember what we said, because meiosis will produce two important cells. Okay, So remember that if a cell divides, basically we're going to have two important cells. We're going to have a large cell which we're calling the secondary oocyte, okay, but with a smaller cell. The smaller cell we call it the first polar body. First polar body. First polar body. Why does that happen? The reason why we're going to have these two important cells is because this, remember what we said here, we had 46 chromosomes in the primary oocyte, okay? But we need to have 23 chromosomes in the secondary oocyte. Where is the other 23 chromosome going? It is going in the first polar body. That's why this first polar body is important, because it's going to carry these chromosomes away from the secondary oocyte. And basically this one is going to it will undergo what we call atresia. Basically it will disappear because we don't need this. Okay, so that is what's going to happen here. And this secondary oocyte, it will continue its journey. Now it will enter into meiosis 2. Okay, meiosis 2. Now what's going to happen is that this secondary oocyte is going to be arrested. Okay, it's going to be arrested in the what? Metaphase 2. Take note of this. So the secondary oocyte, again, the moment it changes into the primary oocyte, the moment it changes into the secondary oocyte, all right? Yes. Now after it changes, then it will start undergoing in the meiosis number 2. Meiosis number 2, but it's going to be arrested in metaphase 2. Then ovulation will happen. After these processes, then that's when ovulation will happen. All right, so we need to take note of that. So these are the very important points that we need to take note. Now, if ovulation happens, now what's going to happen is that the secondary oocyte now is the one that's going to be released in the oviduct, all right? So that now somehow maybe fertilization can happen. If fertilization can happen now, that sperm cell can penetrate the corona radiata, can penetrate the zona pellucidum, so that now, if that happens, there will be now fertilization of that oocyte. The sperm cell and the secondary oocyte will undergo fertilization. But if that happens now, the secondary oocyte will now change into what? The mature oocyte, so that now fertilization can happen completely. All right, so what we're simply saying is that after ovulation happens, so let us write those sequences. After ovulation happens, in case now fertilization happens, okay, in case fertilization happens, then what's going to happen is that this secondary oocyte that was arrested in what? Metaphase 2 of meiosis number 2. All right. If fertilization happens now, this secondary oocyte will change into what? Mature oocyte. How? Because the sperm cell is the one that's going to stimulate this secondary oocyte to change into the mature oocyte. So mean that this meiosis is going to be completed. So this mature oocyte means that meiosis 2 will be what? Completed. So this is what we are saying. And what's going to happen is that if meiosis 2 is going to be completed, then we're going to have what? The second polar body. Okay, remember that the first polar body was getting the chromosome. Okay, now here, what is it getting? It is getting the what? The parts of the chromatid, because in meiosis 2 we're going to just be separating the chromatids of the what? Chromosome. So these, they are going to take away the chromatids, okay, that are not needed in the mature oocytes. Okay. Now, this is the last thing that we need to talk about. Now, the other thing that we need to talk about is that, remember that now ovulation has happened. So what we are going to have is this. Okay, what we're going to have is this cell, this type of a cell. Okay, so if ovulation has happened, means that this egg has gone, this oocyte has gone in the oviduct, so that this process can happen. So what's going to happen is this. So there will be this structure that will be left, which we call what? We call it a corpus luteum. Corpus luteum. Okay, so this structure without an egg inside, we call it corpus luteum. Corpus luteum, it will continue producing estrogen as well and progesterone like that. Okay, to start producing progesterone, estrogen like that, because this is needed to maintain the build-up of the uterus. Right? Then after that, the corpus luteum now, if it becomes atrophied, it will become into what we call corpus albicans. Okay, corpus albicans. So here we had corpus luteum. Now, since now time goes by, this will start becoming atrophied and it will start becoming what we call corpus albicans. So these are the events that will happen in oogenesis. And this is the final thing that we've talked about. All the best, stand well, until next time.